All right, so today in geometry, we're going to finish up chapter 5. So we're going to look at section 5.5, which are inequalities in one triangle. We have a theorem that states in any triangle, the longest side will be opposite the largest angle, which makes sense, right? And the shortest side will be opposite the smallest angle. The converse of that applies too. Remember, converse means we trade places with the hypothesis and the conclusion. So the converse of that would say, in any triangle, the largest angle will be opposite the longest side. And the smallest angle will be opposite the shortest side. All right, so let's practice that. So we have this picture, triangle RAT, R-A-T, and it wants to know what is the longest side and why, and what is the shortest side and why. So the longest side, look at what is my biggest angle. My biggest angle is 75, so directly across or opposite that is side RA. So my longest side is segment RA. Why? It's opposite the largest angle, 75 degrees. Then it says the shortest side, so I look for my smallest angle, which is 50. Opposite that is segment AT. Why? Because it's opposite the smallest angle, 50 degrees. So then picture number 2 gives us triangle SUP. And here it gives me the side lengths, and it wants to know which one is the largest angle and the smallest angle and why. So the largest angle is going to be opposite the longest side. 11 is the biggest side I have, so opposite gets me angle U. So my largest angle is angle U. Why? It's opposite the longest side of 11. The smallest angle, my smallest side is 9. Across from that is angle S. It's opposite the shortest side, 9. Okay. So then number 3, all that they give me are 2 angles, right? 88 and 20. So I can go ahead and find that third angle because, again, remember all 3 angles have to add up to equal 180. So if I do 180 minus 88 minus 20, I find out that this angle down here is 72 degrees. So then the longest side, my biggest angle is 88. So my longest side would be side AC. Again, because it's opposite the largest angle of 88 degrees. The shortest side, 20 is my smallest angle. So BC, because it's opposite the shortest or the smallest angle, 20 degrees. So if they only give you 2 angles of a triangle, remember we can always find the third angle because we know that they all 3 add up to equal 180. All right, so number 4, triangle TOP. Notice that they do not give me the side lengths. They give me 3x, 10x, and 12x. This is just like when we were doing our extended ratios, okay? We don't know necessarily what that side is, but we see the ratio, and so we know that no matter what number we plug in for x, that the 3x, that's going to give me the smallest side. The 12x would give me the largest side. So here where they ask for the largest angle, if 12x would give me the largest side, then directly across is going to be angle O. The smallest angle, okay, 3x would give me the shortest side, so across from that, angle P. And the last one on this side, so it says the largest angle, smallest angle, Y. They give me a side of 5, a side of 6, and then a side of the square root of 7. So we need to know what is the square root of 7, okay? I know that the square root of 9 is 3, right? So I know that this is less than 3, and that's actually good enough to be able to figure out what is the longest side and what is the shortest side, right? Because since this is less than 3, so the largest angle across from the longest side, so that's going to be angle O. And again, it's across from the opposite side. Opposite the longest side, which is 6. The smallest angle, well, this has to be smaller. If this is less than 3, it has to be the smallest. So the smallest angle would be angle M because it's opposite the shortest side. All right, let's look at the back of these. Okay, so sample problem number 1, it says write the angles in order from the smallest to the largest. So my smallest angle is going to be across from 6.4 since that's the shortest side, so that's angle B. So we're going to have angle B, comma. So then 10.3 is next, across from 10.3 would be angle A. And the largest angle would be across from the 12.13 because that's the longest side, angle C. Number 2 says write the sides in order from the shortest to the longest. Again, I'm just going to pay attention to how they ask. So the shortest, so I see 33 is my smallest angle. So across from that, side AC. Then we go to 42, so across from 42 is side BC. And 105 is our biggest angle, so across from that, side AB. So now we're going to look at another theorem we have, the triangle inequality theorem. This says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I have triangle ABC, this is saying that I could take side AB and add to it side BC, and that would be greater than side AC. Or I could take side AB and AC, and that would have to be greater than BC. Or I could take side BC and add to it AC, and that would have to be greater than AB. Okay? So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay? So now we're going to determine, is it possible to construct a triangle with a given side lengths, and explain. So as long as any two sides, okay, when I add them together, they're bigger than the third side. If I were to take the smallest two numbers, so if I take the smallest two numbers, sum, that's greater than the larger number, and that's enough to prove that the triangle, that the three numbers would make a triangle. Right? So on A, it says 6, 7, and 11. If I take the smallest two of those, so 6 and 7 are the smallest. So is 6 plus 7 greater than 11? So what is 6 plus 7? 6 plus 7 is 13. 13 bigger than 11? Yes. So yes, 6, 7, and 11 will make a triangle. 3, 6, 9, take the smaller two numbers. So 3 plus 6, is that greater than 9? 3 plus 6 is equal to 9. Is 9 bigger than itself? No. So 3, 6, and 9 will never be the side lengths of a triangle. 28, 34, and 39. If I take 28 plus 34, is that going to be bigger than 39? Absolutely. Those will make a triangle. If I take 4, 4, and 5, okay, so again, take the smallest two numbers, 4 plus 4, is that going to be greater than 5? 4 plus 4 is 8. 8 bigger than 5? Absolutely. So these are yes. 14, 18, and 2. So notice this time I don't have them written in from smallest to largest. So still take the smaller two numbers. 14 plus 2. Is that bigger than 18? 14 plus 2 is 16. 16 is not bigger than 18. So no, I will never have a triangle where the three side lengths are 14, 18, and 2. 3K, 5K, and 4K. Again, this is like our extended ratio problems, okay? As long as the same number that I'm plugging in for K each time, okay? 3K plus 4K, would that be bigger than 5K? 3 plus 4 bigger than 5? Absolutely. All right. Last page here. It says, okay, now describe the possible side lengths of the third side of the triangle. We have to use an inequality. Okay. So the way that we're going to get our inequality, we're going to use two numbers for the first inequality. Then we're going to use the variable and the smaller number. Okay? So I'll show you what I mean here. So describe the possible side lengths of the third side of the triangle. So they're telling me part A, I have a 5-inch side, a 12-inch side, and then X. They want to know what possible numbers could I have for X. And again, they're going to be more than one correct answer here. It's not just going to be one answer that will work with a 5 and a 12. So how I find that range, okay? So to get the smallest, I'm going to take that variable X, I'm going to add to it, okay, the smallest number here, 5, and say that has to be bigger than 12, okay? Because that's what that triangle inequality theorem told us, the triangle sum theorem, that any two sides added together was bigger than the third side. Okay, so then let's solve this. So if I subtract 5 from both sides, I get that X has to be greater than 7. Okay, so now I want to know, okay, what's the biggest number that I could go up to? So take the two numbers that I have and say, okay, 5 plus 12 would have to be greater than X. So 17 would have to be bigger than X. So any numbers between 7 and 17, okay, so 7, X is between 7 and 17. Those are possible side lengths for A. Okay. So now we're going to do the same thing for B. 12 feet, 18 feet, and X feet. Okay, so take the smallest two, that X, I don't know what that is. So X plus 12 has to be greater than 18. Subtract 12 from both sides. So 18 minus 12 gets me X has to be bigger than 6. So I know my smallest number is 6. X has to be between it. What's the biggest number? Okay, so add the two numbers together. 12 plus 18 has to be bigger than X. So 12 plus 18 is 30. So X has to be smaller than 30. So X has to be between 6 and 30. And C says 7 yards, 13 yards, and X yards. So again, take the X and the 7. So X plus 7 would have to be bigger than 13. Subtract 7 from both sides. X has to be greater than 6. So I know X is between 6 and some other number. So now I take 7 plus 13. That has to be bigger than X. So 20 has to be bigger than X. So X has to be between 6 and 20. Okay, so that's the inequality, all the possible side lengths for that third side of that triangle. Number 8, again, this time they just give me a picture. Describe the possible side lengths of BC in inequality form. So here they just gave it to me in a picture form, but we're doing the same thing. We have 28, 13, and X. So again, I would take X and the smaller side, 13, and say that has to be bigger than 28. Subtract 13 from both sides, and I get X has to be greater than 15. So I know that X is going to be between 15 and something. So now I take the two numbers that they gave me, 28 plus 13, that has to be bigger than X. So 28 plus 13 is 41. So X has to be smaller than 41. So any number between 15 and 41 would work to make this a triangle. All right, number 9, again, same type of thing, only this time, look, I don't have X, I have 2X plus 2. We're still going to do this the exact same way. Okay, so I'm going to take my smallest side, 8, and my variable, 8 plus 2X plus 2 this time, has to be greater than 12. So now I need to combine like terms, so I get 10 plus 2X has to be greater than 12. Subtract 10, so 2X has to be greater than 2, divided by 2X has to be greater than 1. So I know that my X has to be between 1 and some number. Again, how am I going to find out what that number is? Now I take my bigger 2, the 8 and the 12, so 8 plus 12 has to be greater than 2X plus 2. 8 plus 12 gets me 20. The 20 has to be greater than 2X plus 2. Solve this for x, so subtract 2, so get 18 has to be greater than 2x, divide by 2, x has to be smaller than 9. So x can be anywhere between 1 and 9 in order to make this triangle work. All right, so now in class I will have you guys try these on your own, but I'll go ahead and go through the answers with you here. So number 1, it gives us this picture, triangle ABC. We have angle A at 20 degrees, angle B at 85 degrees, and it wants us to list the sides in order from the shortest to the longest. So again, remember the very first thing I would have to do is find this missing side, or sorry, missing angle. So 180 minus 85 minus 20, we find that angle C is 75. So now they want shortest, so the shortest, the smallest angle is A, 20 degrees, so across from that would be side BC. And then 75 is next, so across from that, side AB. And finally, 85 was the biggest one, so side AC. Number 2 says, could these lengths form the side of a triangle? Okay. So all I need to do is take my smallest 2, so 7 plus 8, is that greater than 18? So what's 7 plus 8? 7 plus 8 is 15. 15 greater than 18? No. So no, it would not form a triangle. And finally, if two sides of a triangle are 9 and 12, describe the length of the third side, x, using an inequality. So I take the smaller number and my variable, so x plus 9 has to be greater than 12. So subtract 9, so x would have to be greater than 3. So I know that x is between 3 and, so now I take 9 plus 12, so it has to be greater than x. 9 plus 12 is 21, so x has to be between 3 and 21. Right, so that sums up chapter 5, section 5.5, the triangle inequalities. Your homework today is the 5.5 worksheet that I've printed off for you. Tomorrow we will look at our test review, and then the next day we will take our chapter 5 test. Remember, your chapter 5 test will also have radicals on it again, as well as the chapter 5 and radical vocabulary.